Hey guys, today we're opening a golden eye that stares beyond time itself. Imagine floating in silence, far from Earth, where sunlight fades and the stars are so sharp they look like frozen sparks. Somewhere out there, a machine drifts in that darkness. The James Webb Space Telescope, not just seeing stars, but seeing what they used to be. It's easy to forget that everything you see in the night sky is history. Every photon hitting your eye tonight left its home long ago. Some from before humans walked upright, some before Earth itself existed. The Webb telescope takes that truth and stretches it to the edge of reality. Its mirrors aren't just glass. They're time machines made of gold, finely curved to catch the faintest whispers of ancient light. You can almost picture it, a giant honeycomb gleaming against the blackness, each hexagon catching fragments of the universe's story. Built from beryllium and plated in pure gold, these mirrors were designed to reflect infrared light, the heat that ancient galaxies still emit after billions of years. While our eyes see only visible colors, Webb sees warmth, memory, and the fading glow of creation. When you look at the first images it sent back, those soft, shimmering fields of galaxies, you're not looking at the present. You're peering into an ancient film still playing across the sky. Each light speck is a memory, older than language, older than oceans. Some of it began its journey 13 billion years ago when the universe itself was still glowing from its birth. There's something soothing about that, isn't there? The idea that time is always flowing toward us, that every star's light is a gentle wave across eternity. Webb doesn't fight time, it listens to it. It doesn't rush, it waits. And waiting out there at the L2 point a million miles away means absolute quiet. No sound, no wind. Just cold darkness and the soft hum of its instruments staying perfectly still. You might think of it as a mechanical monk, meditating in space. Every movement it makes is deliberate, mirrors aligning to nanometers, shields unfolding like petals in slow motion. It took decades of work and generations of imagination to give it that silence. The engineers knew to see what no one had seen, it must first become stiller than anything ever built. Imagine floating next to it now. The Earth is a tiny marble of blue far behind you. The sun hides behind a 5-layer silver sail, a sun shield the size of a tennis court. Beneath that thin film, the telescope's heart stays colder than Antarctica's winter, just a few degrees above absolute zero, because even a breath of warmth would drown out the fragile light it's trying to catch. At that temperature, metal behaves differently. Beryllium shrinks and holds its shape with perfect precision. Gold reflects heat rather than light. Every photon Webb captures travels down through its instruments, NIRCam, MIRI, NIRSpec, each one slicing the light into rainbows of infrared data. What we see as an image is, in truth, music, a translation of vibration, distance, and temperature into color. Now think about this. JWST doesn't really see in color. It measures energy, wavelength, intensity. The color comes later after scientists process the data back on Earth, assigning hues to frequencies beyond human vision. When you see that deep purple of a nebula or that golden dust around a dying star, it's an interpretation, a bridge between human eyes and cosmic truth. It's art born from physics. As you listen, picture those first moments after its mirrors opened. 6 golden eyes unfurling into the void, trembling slightly, then locking into perfect symmetry. The telescope looked into nothingness for days, collecting darkness, aligning, focusing. Then, faintly, gently, a star appeared. 1 pixel at first, then a cluster. The universe blinked back. That was the instant humanity looked farther into its own past than ever before. The first calibration image wasn't just a test, it was proof that we could see light older than Earth's crust, older than the atoms in your breath. And for scientists watching from mission control, it was like hearing a heartbeat from the other side of time. You may close your eyes now and imagine that heartbeat as a soft pulse, light crossing the ocean of the cosmos, one photon at a time. Webb listens to it patiently every day, mapping not what's happening now, but what was. That's its paradox. To see the future of our understanding, it must live forever in the past, wherever you are. Let the world slow down for a while. Soften your gaze, let the hum of life around you fade, and gently drift with us into tonight's quiet exploration. The silence around the telescope is almost impossible to describe. It isn't the kind of quiet you find in a forest or deep beneath the ocean. It's something purer. The silence that existed before sound was ever born. Out there, 1.5 million kilometers from Earth, JWST floats at a place called the Second Lagrange Point, or L2. If you could see it from a distance, it would appear motionless. But in truth, it's falling, always falling, orbiting the Sun in perfect rhythm with Earth, tucked safely in our planet's shadow. The Sun, Earth, and telescope form a perfect line, like beads on an invisible thread of gravity. In that position, JWST can stare endlessly into deep space without ever being blinded by daylight. You might picture it as a golden leaf drifting above a silver ocean. The sun shield, thin as a human hair, protects it from the warmth of the sun, the glow of the moon, and even Earth's own heat. Each of the 5 layers reflects light, scattering it until only the faintest trace reaches the instruments. That's why JWST's heart stays colder than the coldest winter on Pluto, around 40 Kelvin. It's strange to think that silence and cold are the very things that make it alive. Every system on board, gyroscopes, star trackers, reaction wheels, is tuned to maintain absolute balance. A single nudge from a micrometeor could throw off its aim. So, engineers taught it how to correct itself, to breathe, adjust, and hold still again. In this way, it's not a telescope, it's a dancer, moving so slowly you'd swear it's frozen in time. At L2, day and night no longer exist. There is only darkness. Beyond the sunshield, the stars never set. Webb's field of vision stays open, unblinking for months. It points at ancient clusters, baby stars, ghostly nebulae, and sometimes just empty space. Because even the emptiness might contain light we've never noticed before. The stillness of that orbit has another kind of poetry. From here, time feels slower. If you were standing on one of the telescope's golden mirrors, which of course you never could, the sun would never rise or set. Earth would remain a small blue marble forever, hanging near the edge of the black. You'd hear nothing, not even your own heartbeat. Yet beneath you, a machine hums with quiet intelligence, waiting for photons that left their source before the sun was born. Think about that. Light traveling billions of years just to end its journey here on a sheet of gold the size of your hand. It's humbling. And it's exactly why scientists chose infrared for Webb's eyes. Infrared light stretches as it travels through space, its wavelength growing longer as the universe expands. Visible light from the first galaxies has been stretched so far, it's no longer visible at all. Only a telescope like JWST can catch it, like a fisherman casting a net into the river of time. Every photon that strikes its detectors carries a secret. How far it's traveled, how much the universe has grown since it left home, what kind of stars or gas clouds it passed through. When those bits of light reach Webb's sensors, they're turned into electric signals, beamed back to Earth across 1 million miles. There, in data centers on our planet, the signals become pictures, windows through which we see the dawn of everything. You might wonder what it's like for the engineers who watch over it. Every day, they receive streams of numbers, not images. A line of data here, a temperature reading there. They must interpret those codes, translate the machine's whispers, When a new data set arrives, they hold their breath, because any fluctuation could mean a discovery, or it could mean a malfunction. Out there, you don't fix things. You only trust them. That trust was born out of 20 years of trial, error, and near heartbreak. Webb almost never made it off the ground. There were delays, funding battles, even doubts that it would ever work. But on Christmas Day 2021, it rose from the coast of French Guiana, folded neatly like an origami bird. For weeks it unfolded piece by piece, every latch and hinge performing a choreography that had never been tested in space before. It was a gamble with no second chance, and somehow it worked. Every mirror aligned, every sail caught its balance. When it finally reached its orbit around L2, engineers back on Earth wept. Not because they were scientists, but because they were human. They had built something that would outlive them, something that could see the birth of galaxies. If you close your eyes now, you can imagine it drifting in that infinite calm. No up, no down, just a steady hum of data pulsing through space. The gold mirrors glint faintly, catching invisible light. Its instruments, NIRCam, NIRSpec, MIRI, each tuned like a musical instrument, listening for a cosmic symphony that began before time had a name. It's peaceful there, the kind of peace humans have searched for in temples, deserts, and dreams. Out at L2, the Webb telescope listens to silence and finds meaning in it. It watches the slow breathing of the universe, galaxies expanding, stars collapsing, atoms rearranging themselves in endless cycles. And while we sleep, it keeps watch. The golden eye never closes. Somewhere out there, in that frozen silence, it waits for the next photon, a tiny messenger from another age, traveling billions of years just to whisper, "I was here." When the telescope finally arrived at its post, the next task was to give it sight. Imagine 6 weeks of tension, thousands of engineers back on Earth holding their breath, waiting for a mirror to open its eyes for the first time. JWST wasn't launched as one solid mirror. It was folded up like a sleeping insect with its golden wings tucked close. Each of its 18 hexagonal mirrors had to unfold, move, and lock into position with accuracy smaller than the width of a human hair. 6 gold eyes. That's what they looked like, glinting faintly against the endless void. They were made of beryllium, a metal both strong and light, coated in an ultra-thin layer of gold, just 100 nanometers thick. Gold wasn't chosen for beauty. It was chosen because it reflects infrared light better than any other metal known to science. At first, all 18 mirrors saw the universe separately, sending back 18 blurred images of the same star. Slowly, day by day, the mirrors adjusted, each one bending ever so slightly through a mechanism called an actuator. Imagine microscopic motors pushing and pulling each mirror into harmony until, after weeks of fine-tuning, those 18 stars became one. The telescope's sight came into focus, titling the sharpest in human history. That first star wasn't just a test. It was a promise fulfilled. Scientists called it HD 84406, an unremarkable sun-like star in the constellation Ursa Major. But for those who had worked on Webb for decades, it became something sacred. When the calibration image appeared on their screens, one perfect, crisp point of light surrounded by thousands of distant galaxies, there were tears, applause, even silence. The kind of silence that comes only when wonder takes your breath away. Think about that for a moment. One speck of starlight, sharper than any camera on Earth could ever capture. It wasn't just seeing, it was hearing the ancient hum of the universe for the first time in clarity. The mirrors, now aligned, formed a single golden eye, capable of looking so far that it could witness galaxies forming only a few 100 million years after the Big Bang. Each mirror plays a note in a cosmic chord. Together they hum in perfect resonance. The structure is so precise that if one mirror were off by a fraction of a wavelength, the entire telescope would lose focus. But they hold, balanced in cold perfection. The engineers gave it a ritual. Every few days, it adjusts itself automatically, shifting slightly to stay in harmony as the telescope breathes in the temperature of space. From that moment on, JWST began collecting data. Endless streams of infrared light turned into patterns, maps, and colors. The mirrors, polished to atomic smoothness, catch photons that have traveled billions of years. The idea is almost impossible to comprehend. These photons left their galaxies before Earth even existed. They have crossed an expanding universe, stretched thinner and colder by time, until finally, they strike the telescope's sensors, whispering stories from the dawn of creation. When you see those hexagons glowing in photographs, think of them as symbols of patience. Each one represents decades of design, arguments, failures, and faith. They had to survive launch vibrations, the freezing vacuum of space, and the uncertainty of deployment. And yet here they are, floating, glimmering, perfect. In a sense, the mirrors are like eyes not only for science, but for humanity itself. They reflect what we've always wanted, to understand where we come from and maybe where we're going. The JWST doesn't just take pictures. It translates silence into vision. It takes the dark and turns it into meaning. There's a kind of poetry in its symmetry. The hexagonal design isn't just efficient, it's elegant, like honeycomb built by cosmic bees. Nature loves hexagons, snowflakes, crystals, and the facets of insect eyes. The engineers followed that same logic, creating something that feels both mechanical and organic, human and alien all at once. You can almost imagine the telescope itself dreaming, its golden face turned toward infinity, capturing fragments of time piece by piece, each hexagon catching a different part of the story. One glimpses a dying star, another a newborn one, another the faint haze of an unseen galaxy, and together they weave the first clear image of eternity. Some scientists say that if you could see what JWST sees in real time, you'd cry. Not from sadness, but from awe. The scale, the light, the silence, it's overwhelming. Because it reminds us that everything we are, everything we touch was once part of that same starlight. So, as you breathe slowly now, imagine those 6 golden eyes polished to perfection, gazing into the endless night, each mirror catching the faint echo of a universe still unfolding, each reflection carrying not just light, but memory, and somewhere deep inside the telescope, that memory becomes a picture, the first true glimpse of what lies beyond time. Every beam of light that touches the James Webb Space Telescope carries a secret older than Earth itself. When you stare up at the stars, you're not seeing what is, you're seeing what was. And for Webb, that difference stretches across billions of years. The light it collects tonight may have begun its journey when the universe was still a newborn, a few 100 million years old, dense, hot, and bursting with stars for the very first time. Those photons have been traveling ever since, crossing oceans of expanding space, stretched thinner and redder as the universe grows. By the time they reach JWST's golden mirrors, their wavelengths are no longer visible to human eyes. They've become whispers in infrared, light so faint, so old, it's more memory than brightness. This is what astronomers mean when they say, Webb can see back in time. It's not fantasy, it's physics. The farther away an object is, the longer its light has taken to reach us. Look at the moon and you see it as it was 1 second ago. The sun, 8 minutes ago. But when JWST gazes into the deep field, it sees galaxies as they were 13 billion years ago, when the first stars had only just begun to burn. Pause for a second and let that sink in. Those galaxies no longer exist in that form. Many have collided, changed, or disappeared entirely, but their light, their final echo, has only just arrived. In every image JWST sends back, you're not looking at space. You're looking at time made visible. It's humbling, isn't it? The idea that the past still exists, shimmering faintly across the dark. When you see one of Webb's deep field photos, with hundreds of spiral and elliptical galaxies scattered across the frame like cosmic fireflies, each point of light is a fossil of existence, the last heartbeat of something impossibly far away. Webb's instruments, NIRCam and MIRI, are designed precisely for this kind of archaeology. They peel away the darkness like layers of ancient dust, revealing the faint infrared glow of the first structures in the universe. It's almost like walking into a cave and finding paintings drawn in starlight. There's one image that captures this feeling perfectly. SMACS 0723, the first deep field released to the public. At first glance, it's just a collection of bright dots. But zoom in and you realize every dot is an entire galaxy filled with billions of stars. Some of that light left its home when our universe was less than a tenth its current age. When dinosaurs would one day exist, that light had already been traveling for billions of years. Scientists call it a cosmic time machine, and it truly is. Because each photon Webb catches is a traveler, carrying a story across unimaginable distances. The telescope reads those stories through something called redshift, the stretching of light as the universe expands. The higher the redshift, the older the light. And JWST was built to read the highest redshifts ever measured. In its first year alone, Webb spotted galaxies that shouldn't have been there. Massive, mature systems forming far earlier than any model predicted. The data puzzled scientists. How could galaxies that large exist so soon after the Big Bang? Were we wrong about how fast matter gathered? Or are there processes we don't yet understand? Dark matter working overtime, or new laws of physics waiting to be discovered? That's the beauty of it. Webb doesn't just answer questions, it creates better ones. Every image deepens the mystery. Every color, every faint halo of dust reminds us that our cosmic story is still being written. And yet, beneath all that grandeur, there's something deeply peaceful about it. To look at light that old is to feel time slow down. You realize that everything changes, but nothing truly vanishes. The photons from a vanished galaxy still find their way to you. The atoms in your body once belonged to those same explosions of light. Think of it this way. The gold on JWST's mirrors was forged in the death of a star billions of years ago. Now it reflects light from stars just being born. The past is literally seeing the future. You might close your eyes and picture it, a single photon born in a burst of ancient fire, racing through cold and silence, slipping past clouds of dust, bending around galaxies, until finally, at last, it lands on a mirror made by beings who can wonder. For that photon, the journey ends. For us, it begins. This is what it means to see beyond time. Not to escape it, but to understand how deeply we're woven into its fabric. The Webb telescope isn't looking out there. It's looking back. Back into the first dawn, back into our cosmic childhood, back into the moment when existence itself began to glow. So tonight, as you drift further into calm, imagine that faint ancient light washing over you. Soft, red, endless. You are watching the birth of everything. The first galaxies Webb revealed weren't majestic spirals or grand clusters like we see in textbooks. They were small, chaotic, and imperfect. But they were the first. Tiny knots of stars burning through a sea of hydrogen, flickering like newborn candles in an infinite night. And yet, to the human eye, they look impossibly beautiful. Because in those faint smudges of light lies the very beginning of structure. The moment the universe began organizing itself into something that could one day create us. When the first JWST deep field images appeared, Scientists were stunned. Galaxies with redshifts of 13, 14, maybe even higher, meaning their light had traveled more than 13.4 billion years. The telescope was, quite literally, seeing the universe, as it was a few 100 million years after the Big Bang. No other eye had ever looked this far. Hubble could only glimpse that early dawn in hints and blurs. Webb made it clear. But what Webb saw didn't entirely make sense. Those first galaxies were too bright, too massive, too evolved for such an early age. Some of them looked like mature systems that, according to our theories, shouldn't exist for another billion years. It was as if the universe had skipped steps, as though creation had hurried, impatient to shine. Astronomers debated, were these truly ancient galaxies, or was something else at play, perhaps gravitational lensing, distorting our view and making young galaxies appear older and larger? Or maybe, just maybe, our understanding of cosmic evolution needs rewriting. Webb had already begun to challenge everything we thought we knew about the timeline of existence. To visualize this, imagine standing on a beach at dawn, watching the very first waves form after a calm night. Each ripple carries energy from far below the surface, forces you can't see but can feel. Those first galaxies are like that, ripples in the cosmic sea, evidence of hidden forces shaping the newborn universe. Inside them, the first stars, called population 3 stars, were burning with a brilliance the universe has never seen again. They were gigantic, hundreds of times the mass of our sun, burning hot and fast, living brief but spectacular lives. When they died, they exploded in supernovae that seeded the cosmos with the first heavy elements. The building blocks of everything solid, planets, rocks, and you. Before them, the universe was almost pure hydrogen and helium. No carbon for life, no oxygen for breath, no iron for blood. It was these first stars, the ancestors of all things, that began the chain of creation. When Webb captured the faint, red glow from those ancient regions, it wasn't just photographing galaxy, i.e., it was watching the universe forge the ingredients of life itself. One of the first targets was the galaxy cluster known as Glass Z13. Its light began traveling when the universe was just 300 million years old, barely 2% of its current age. For comparison, if the entire cosmic timeline were a 24-hour day, that galaxy existed just 7 minutes after midnight. And yet, in Webb's images, you can see it, a small glowing ember suspended in darkness, a whisper from a time when galaxies were just beginning to breathe. Scientists compared Webb's findings with Hubble's earlier data, overlaying the two like layers of history. What once looked empty now teemed with stars. Areas Hubble had seen as black voids turned out to be crowded with faint galaxies, their light stretched into deep, crimson tones. The universe wasn't empty at all. It was overflowing with creation. Think of how profound that is. For billions of years, that light wandered alone through space, unseen. Then one night, a human-made mirror finally caught it. For the first time, those ancient photons met eyes that could understand what they meant. In that meeting, between starlight and consciousness, something deeply poetic happened. The universe through us became aware of itself. Webb's images of early galaxies aren't just data, they're memories, visual evidence of when time itself was young. Each blurred speck holds entire histories of star birth, collisions, black holes forming, and gas clouds cooling. When astronomers reconstruct that story, they're not just studying physics, they're reading the first chapter of existence. If you look closely at those images, you might notice something subtle. A pattern of spirals, arcs, and clusters repeating across vast distances. It's as if the universe, even in its infancy, already had a sense of rhythm. chaos giving birth to symmetry. That quiet order among the stars is what eventually allowed galaxies like our Milky Way to form. And much, much later, for one small blue planet to wonder about it all. And tonight, as you rest, let that thought soothe you. The light from the first galaxies, older than mountains, older than Earth, has finally found you. It traveled through everything, dust, gravity, time itself, just to arrive here, in this moment of calm, where you can simply breathe and listen. Because the story of those galaxies isn't over. It continues in your atoms, your breath, your heartbeat. You are made of their remnants. Starlight turned into being. Webb isn't just seeing back in time, it's seeing you in the making. Now follow that ancient light deeper into the glowing clouds where new stars are still being born. These are the places astronomers call stellar nurseries, vast regions of gas and dust where gravity gathers the raw ingredients of creation. JWST's golden eyes can see through the dense curtains of that cosmic fog, revealing forms and movements that were invisible even to Hubble. Perhaps the most famous of them all is the Pillars of Creation. You've probably seen that image. Tall columns of gas and dust standing like ghostly mountains against a backdrop of glowing stars. Hubble first revealed it in 1995, its tendrils of shadow and light inspiring a generation. But when Webb turned its infrared gaze toward the same region, the scene transformed. The darkness dissolved. The pillars became transparent, filled with newborn stars sparkling inside them like embers within smoke. It's breathtaking to realize that what looked solid, invisible light is actually porous, a storm of motion and birth. Webb's infrared vision pierces through those clouds, showing stars only a few thousand years old, still wrapped in the cocoons of gas that formed them. It's like seeing the universe breathe, one slow exhale at a time. Inside the Carina Nebula, another cosmic nursery, JWST captured something no human had ever seen so clearly. The edges where chaos becomes order. The Carina Nebula is immense, hundreds of light years across, and filled with towering ridges of dust shaped by the radiation of massive young stars. Webb's image of it looks like a sunrise frozen in eternity, the boundary between light and darkness glowing in ethereal blue and gold. Astronomers nicknamed it the Cosmic Cliffs. At its edge, new stars ignite in waves, carving valleys and peaks out of gas that has drifted for eons. If you could stand there, which of course no one ever could, you'd see light rippling across clouds the size of entire solar systems, hear nothing but silence, and feel the slow, invisible tug of gravity sculpting futures. Every photon JWST collects from these regions tells a story of transformation. In these nurseries, hydrogen becomes helium, helium becomes carbon, and so on, the universe recycling itself endlessly. The light from these newborn stars carries the same code as the light from the first ones, but it's fresher, softer, like a lullaby compared to a hymn. And there's something deeply emotional about it. The same forces that created these stars are still at work in you. The iron in your blood, the calcium in your bones, the oxygen you breathe, all forged in furnaces like these billions of years ago. When JWST peers into the pillars or the Carina Nebula, it's not just studying distant phenomena, it's watching the same process that made life possible here. Look closely at Webb's images and you'll see trails of dust streaming away from stars that have just ignited. Each one is like a cosmic cradle, releasing its newborn into the universe. Some will grow into systems with planets and moons, Others will die young, exploding and scattering their essence to start the cycle again. It's creation and destruction, dancing hand in hand. And Webb records it all with the quiet patience of eternity. To truly grasp it, imagine lying on your back beneath those clouds, though of course you couldn't survive there. You'd see colors no eye could perceive, infrared glows blending into ultraviolet shadows, filaments of energy twisting through the vacuum. The air would be thick with light, if there were air at all. It's not chaos you'd feel, it's rhythm. Every star's birth pulses like a heartbeat in the body of the cosmos. This is where the universe practices balance, where gravity pulls inward and radiation pushes outward, where collapse becomes creation. JWST lets us witness that balance, that fragile harmony, from a million miles away. And in doing so, it reminds us that everything, even something as vast as the universe, moves according to the same quiet rhythm that beats within us. The first. Time scientists processed Webb's image of the Carina Nebula. They described it as the edge of eternity. You can see why. The image looks alive. The dust glows like golden mist, and stars burn like lanterns suspended in fog. There's no sense of scale, no up or down, only movement, waves of birth rolling across light years of silence. As you breathe slowly now, imagine those waves still moving, still shaping, still glowing in infrared. The telescope is watching them even as you listen.
It doesn't hurry. It doesn't blink.
It just observes, quietly translating light into knowledge, chaos into beauty, and somewhere in that beauty lies a reflection of us. Fragile,
Luminous, always becoming, because the universe is not finished creating.
It never was. Beyond the bright clouds where stars are born, there lies a softer, quieter realm, a place where light bends, scatters, and sometimes disappears. It's here that JWST begins to see something stranger than galaxies and nebulae, the shadows of invisible matter. Astronomers call it dark matter, but that name is almost misleading. It isn't dark like the absence of light. It doesn't absorb or reflect anything. It's transparent, completely invisible to every telescope ever built.
And yet it makes up about 85% of all matter in the universe.
Everything we can see, every star, planet, atom, accounts for less than 1/5 of what actually exists. So how can something unseen hold galaxies together? Webb was never designed to see dark matter directly, but it can trace its fingerprints. When light from distant galaxies passes near massive clusters, the gravity of dark matter bends that light, a phenomenon called gravitational lensing. The result is a cosmic distortion. Galaxies appear stretched, doubled, or warped around invisible shapes, like reflections on rippling water. Webb's images reveal these distortions in stunning detail. In them, astronomers can map the unseen. It's not by light, but by how light behaves. Every curve, every arc in those deep fields becomes a clue, allowing scientists to reconstruct the invisible scaffolding that shaped the cosmos. Think of it like wind moving through tall grass. You can't see the wind itself, but you can see the way it bends each blade. In the same way, Webb sees how dark matter bends the fabric of space, sculpting galaxies into spirals and filaments. What we once thought of as empty space is actually a vast, interconnected web, the cosmic skeleton of existence. Some of Webb's most remarkable data comes from a cluster called SMACS 0723, the same region that produced its first deep field image. When scientists analyzed the distortions in that picture, they found that invisible halos of dark matter were bending light from galaxies even farther away. Those arcs of light aren't random. They're the visible edges of an invisible empire. It's a strange feeling, isn't it? To know that most of reality is hidden, that the brilliant stars we see are just sparks on a massive, unseen framework. But there's something calming about it too. The idea that even in darkness there is structure, pattern, order. The universe holds itself together not through chaos, but through harmony, gravity's silent hand guiding everything toward balance. Some researchers believe that without dark matter, galaxies couldn't exist at all. Stars would scatter apart like sparks from a fire. The invisible mass acts as glue, holding them together across billions of years. So when JWST captures light bending through those clusters, it's not just imaging ancient galaxies, it's catching a glimpse of the cosmic architecture that made everything possible, and the mystery goes deeper. For every place dark matter bends light, there's another place where it seems to pull differently, as though something else, something even stranger, is shaping space. Some think it might be a hidden form of energy. Others suspect the laws of gravity themselves might behave differently on cosmic scales. Webb's precision may someday help answer that. By comparing what it sees with what should be there, we can start to outline the unknown. There's beauty in that uncertainty. To stare at a Webb image, knowing that much of what you're looking at isn't there at all, at least not visibly, is to feel humility. It's a reminder that knowledge doesn't banish mystery, it deepens it. If you look again at one of those deep field photos, the tiny arcs of light curved like smiles against black space, imagine them as echoes. They're not accidents of the camera. They're the marks of invisible giants, the fingerprints of gravity itself. And perhaps that's the quiet lesson of JWST's journey. The most important things in the universe aren't what we can see, but what holds what we see together. As you drift further into calm, picture that invisible web stretching across infinity, strands of gravity linking every star, every atom, every heartbeat. You are part of it too. The same unseen force that binds galaxies keeps you anchored to the world beneath you. You belong to this great cosmic balance. Somewhere far away, JWST keeps mapping those ghostly lines of light, tracing the unseen shape of creation. It can't see the dark matter directly, but it knows where to look. And in its silence, it reminds us that the universe is more than light. It's the space between the stars that gives light its meaning. What happens when light bends? Not because it passes through glass or water, but because it moves through time itself. This is the riddle JWST helps us watch unfold, the moment when the universe turns its own gravity into a lens. Einstein first predicted it. Light doesn't always travel in straight lines. Wherever there is mass, a planet, a star, a galaxy, space-time curves, and light, ever obedient, follows that curve. So when light from a distant galaxy passes by something massive, like a cluster of galaxies or even a hidden cloud of dark matter, it bends, splits, and magnifies. It's called gravitational lensing, one of the universe's most poetic tricks. Through Webb's eyes, this isn't a theory, it's a living scene. Look at the deep field images again. You'll notice arcs and rings of light, delicate curves surrounding bright clusters. Those aren't galaxies shaped that way. They're mirages in time. The light from galaxies far beyond them has been warped by gravity, stretched into luminous ribbons. You're not just looking at distance, you're looking at time folding back on itself. To grasp it, imagine holding a crystal sphere in front of a candle flame. The light bends, multiplies, and forms halos. Now replace the glass with a galaxy cluster weighing a quadrillion suns. The result is the same, but cosmic. Some of those arcs in Webb's photos show the same galaxy multiple times, reflected across space-time. One object seen from many paths, one moment replayed by gravity. This is what it means to see time bend. Webb's detectors are so sensitive that they can measure these distortions precisely, turning them into maps, not of light, but of the invisible forces shaping it. Each warped image becomes a clue about the distribution of dark matter, the expansion rate of the universe, and the rhythm by which galaxies formed. The beauty of gravitational lensing is that it makes the impossible visible. Distant galaxies, far too faint for any telescope to detect, are suddenly magnified, brightened by gravity's natural magnifying glass. It's as though the universe itself wants us to look deeper, offering brief windows into its most secret corners. One of Webb's first images of this kind showed Einstein rings, perfect circles of light where the alignment between the observer, the lens, and the distant galaxy is exact. They look like halos made of time. The light that forms those rings has traveled billions of years, detoured by massive objects along the way, arriving at Webb's mirrors from multiple routes. Each photon has taken a different journey, but all of them carry the same story, and that story is delicate. Because light travels at a fixed speed, what Webb captures in those rings isn't just distance, it's chronology. The same galaxy can appear at different stages of its life in the same image. One side shows it as it was billions of years ago. Another shows it slightly older, all in one frame. Time itself becomes layered, folded, almost alive. For scientists, this is a gift. They can measure cosmic expansion by how stretched those layers are, how much light is delayed or magnified. For the rest of us, it's a kind of cosmic poetry. Proof that time is not a single thread, but a fabric that can twist, curve, and reflect. There's a calm wonder in realizing this. Every photon Webb catches has traveled along the curve of reality itself. Gravity doesn't just pull, it sculpts time. And when you look at one of Webb's gravitationally lensed images, you are, in a sense, seeing the past and future meeting halfway. Close your eyes for a moment. Picture space as a dark ocean. Now imagine tossing a stone, a galaxy, into it. The ripples spread outward, bending the paths of everything around them. That's what the universe does, endlessly. And JWST is the diver floating above it, watching the ripples form patterns, tracing their meaning. In some sense, gravitational lensing is the universe speaking in reflections, repeating itself, allowing us to see the same moment from different perspectives. Webb doesn't just collect that light, it translates it into a language of geometry and glow, where time becomes visible. And as you breathe slower, you can almost feel it, time itself bending gently around you, the same way light bends around galaxies. It's not a force that pushes or pulls, it's a rhythm, smooth, patient, inevitable. The same rhythm that governs galaxies, oceans, and heartbeats. Tonight, the telescope continues to watch those arcs of light, patient as ever. Somewhere out there, gravity is curving another beam, sculpting another reflection, sending one more message from the edge of eternity. And when that photon finally reaches Webb's golden mirrors, the story of time will begin again. Another moment, bent but unbroken. Because in the end, nothing in the universe ever truly vanishes. It only travels, and sometimes it curves. Beyond galaxies and the filaments of dark matter, JWST turns its attention towards smaller, quieter worlds. Planets that orbit distant stars. These are exoplanets, and the telescope studies them not through images but through the light that filters through their atmospheres. It listens to whispers, not shouts. When an exoplanet passes in front of its star, a small portion of the starlight travels through the planet's thin atmosphere before reaching us. Hidden in that faint dimming is everything, the fingerprint of the planet's air, its chemistry, even the faint possibility of life. JWST was built to read those fingerprints in detail. Its instruments, NIRSpec,
Niris and Miri, split that light into a rainbow of infrared wavelengths,
allowing scientists to detect the tiniest dips and rises in intensity. Each dip corresponds to a molecule absorbing light: water vapor, methane, carbon dioxide, oxygen. The result isn't a picture but a graph, a delicate wave that tells the story of a distant sky. One of JWST's first triumphs was studying a planet called WSP-39b, a gas giant orbiting a Sun-like star 700 light-years away.
It isn't a place we could ever visit. Its atmosphere is hot enough to melt metal, its clouds made of silicates and sulfur.
But Webb found something extraordinary there, the unmistakable signature of carbon dioxide. It was the first clear detection of that gas in an exoplanet's atmosphere, a proof that the telescope could read the chemistry of alien worlds with precision finer than any instrument before it. Then came WSP-18b, a super-hot Jupiter, where Webb detected signs of water vapor swirling in a planet hotter than molten rock. The data revealed wind patterns, layers of temperature, and even hints of how the planet's atmosphere might mix and flow, all inferred from faint ripples of infrared light. What Webb sees isn't life itself, but the conditions where life might exist. The balance of gases, the pressure, the chemistry. It's looking for what scientists call biosignatures, molecules like oxygen, methane, or ozone that on Earth are tied to living processes. Someday soon, when Webb points at a rocky planet in a star's habitable zone, those same signatures could reveal something we've dreamed of for centuries, a living world beyond our own. Imagine that moment. Somewhere light years away, a small planet passes in front of its sun. Its atmosphere glows faintly in infrared, invisible to human eyes but clear to Webb's gaze. The light that escapes carries clues about oceans, clouds, perhaps even green continents, all encoded in waves of energy so subtle they could be drowned out by a whisper. And yet JWST catches them. It listens with infinite patience. The telescope doesn't look at these planets directly. Instead, it studies their shadows. It's like watching a candle flicker behind colored glass. By reading the changes in color, you can tell what the glass is made of. Webb reads that cosmic glass, molecule by molecule, building an invisible picture of the unseen. Every signal it catches is fragile, fleeting, sometimes just a handful of photons. But each one bridges the distance between stars. They left their homes long before we built the telescope, traveled through cosmic storms and clouds of dust, and finally, after centuries or millennia, touched gold. And in that instant, their meaning became clear. You are not alone, for now. The search continues with worlds like TRAPPIST-1, a system of 7 Earth-sized planets orbiting a small red star just 40 light-years away. Webb has already begun studying their atmospheres, searching for hints of water and carbon dioxide. Imagine it, 7 potential homes, each one different, each one waiting to tell its story. But even if we never find life, Webb's discoveries already change how we see ourselves. For the first time, we can sense the weather on worlds hundreds of trillions of miles away. We can watch their sunrises and sunsets in wavelengths no human will ever see. We can measure the heat of alien skies from the quiet of our own. There's a strange peace in that, knowing that across the endless dark, the universe holds more worlds than there are grains of sand on Earth. Some may be barren, others bursting with unseen color. And each time Webb catches a faint transit, it's as if the cosmos is exhaling softly, saying, "Look closer. I have more to show you, so as you drift into calm, imagine floating near one of those distant suns." The planet's edge glows in twilight. A thin ring of atmosphere gleams in gold, scattering the last light of its day. Somewhere beyond it, the telescope waits, listening for that light to arrive, a light older than memory, carrying the scent of possibility. And maybe, just maybe, when that signal reaches us, we'll realize that the universe has been whispering all along. And Webb, patient and golden, was simply the first to hear it. The deeper JWST looks, the more it begins to notice something faint but ever-present. A soft veil between galaxies, a haze of light that refuses to fade. Astronomers call it cosmic dust, but the name hardly captures what it truly is. It's not like the dust in your home or the sand on Earth. These particles are microscopic remnants of dying stars, atoms of carbon, silicon and iron drifting freely between suns, the ashes of creation. To Webb, dust is both an obstacle and a treasure. It hides what's behind it, swallowing light and confusing cameras built for visible wavelengths. But in the infrared, dust becomes luminous. It glows with its own warmth, faint and red, like the last coals of a fading fire. And that's where JWST shines. It sees through the dark, peeling back the layers to reveal what lies beyond. In the early universe, dust was scarce. The first stars were made almost entirely of hydrogen and helium, their explosions seeding the cosmos with heavier elements. Over billions of years, that dust gathered, merged, and built everything solid we know. Planets, moons, life, all born from the residue of death. Every grain tells a story, a history of cosmic recycling. When JWST peers into galaxies far away, it sees not just stars, but echoes of stars. Clouds of dust left behind after supernovae,
floating across interstellar space.
Sometimes the light from a background galaxy filters through these clouds, letting scientists read their composition like ancient manuscripts. The data reveals silicates, carbon chains, even the first hints of organic molecules. It's astonishing to think that the building blocks of life existed long before life itself. Long before Earth cooled, the universe was already making carbon. Every time a star dies, it releases a bit more of it into the dark. Webb's instruments can detect these tiny traces, the spectral fingerprints of dust, showing how each generation of stars enriches the next, one of Webb's first. Observations focused on supernova 1987A, the closest supernova seen in centuries. Deep in its expanding shell, Webb found fresh dust forming in real time. Billions of tons of it, enough to make thousands of planets. For decades, astronomers wondered how the early universe filled with dust so quickly. Webb showed that even in death, stars work fast. The cycle of destruction and creation has no pause. In another image, Webb turned its eyes toward the Tarantula Nebula, a star-forming region 160,000 light-years away. There, among clusters of hot blue stars, it saw rivers of dust glowing in gold and copper hues, sculpted by radiation into tendrils and waves.
It looked like smoke frozen in eternity.
But in that smoke, new worlds are taking shape. Solid particles clumping together, grains forming pebbles, pebbles forming planets. To the human eye, dust means obscurity. To JWST, it means history. The faintest infrared glow from a dust cloud carries the memory of everything that came before it. The deaths of stars, the collisions of galaxies, the birth of the elements. It's the residue of the universe learning to build itself. And there's something poetic in how Webb translates it. The telescope doesn't just reveal light, it reveals what light leaves behind. It sees the fingerprints of time itself. Trails of ancient energy frozen in motion. If you close your eyes, you can almost imagine that dust. Tiny particles drifting in a silent sea of gravity, each one glowing faintly like sparks floating above invisible fires. Some will fall into the pull of young stars, becoming part of new worlds.
Others will wander for billions of years before joining something else.
The universe wastes nothing. Even here, on Earth, the dust that settles on your windowsill may contain atoms forged in those same supernovae. You breathe them, touch them, live through them. The connection is intimate, cosmic, yet personal. The same carbon that glows in Webb's images burns in your blood. So when you see one of those deep,
red-tinted pictures and a field of faint galaxies wrapped in golden mist, remember that you're looking not just at light, but at memory made visible.
the universe remembers every explosion, every spark, every transformation. Webb just helps us read the story. And as the telescope drifts silently at L2, collecting more of those faint whispers, it continues to listen to the echoes of long-vanished stars. That's what cosmic dust really is, the echo of everything that's ever lived. Tonight, as you rest, let that thought settle like stardust around you. Nothing truly ends. Every atom finds its way back to light.
Every flame, no matter how distant, leaves a trace.
And when the universe breathes out, it's dust that carries its story across time. Then came the image that changed everything, the deepest image in human history. Released to the world in July 2022, it was the first full-color deep field from the James Webb Space Telescope. The target, a tiny patch of sky, no larger than a grain of sand held at arm's length. For most of human history, that patch was empty.
Nothing there but blackness.
But when Webb opened its golden mirrors and stared for just 12.5 hours, the darkness bloomed with light. In that single frame, a photograph smaller than your fingernail, there were thousands of galaxies, spirals, clusters, arcs of light stretched by gravity, faint smudges glowing from the edge of time itself, each one a city of billions of suns, each one a piece of the cosmic mosaic. The image was called SMACS 0723, and the moment it was shown to the world, it silenced the room. Even scientists who had spent decades studying galaxies stared in disbelief. One said, "Every pixel is a mystery." Another whispered, "We're looking at the first sunrise the universe ever made." At first glance, it's overwhelming. So many points of light, so much depth. But look closer and you realize you're seeing the oldest light ever captured, traveling for more than 13 billion years before finding the mirrors that could hold it. That light began its journey when the first stars were still igniting, when galaxies were just forming from clouds of hydrogen. The image feels infinite, but it's not just vastness that makes it so moving.
It's intimacy.
Because in that sea of galaxies, you're looking at everything that ever could be. Each small swirl of color contains countless stars, planets, perhaps even life. And yet, all of it fits into a picture that could rest on your palm. JWST's infrared sensors reveal details Hubble never could. Subtle reds and golds where visible light fades. The faintest galaxies appear not white, but copper and amber, their light stretched by the expansion of the universe. The deeper you look, the older they are. It's like peeling back the layers of time until you touch the beginning. In the foreground of the image, you see arcs, curved streaks of light forming delicate loops. That's gravitational lensing again, the signature of invisible mass bending light from galaxies behind it. Some of those arcs represent galaxies magnified dozens of times, their light stretched and mirrored by the cluster's gravity. So even within one photo, you're seeing the same object at multiple moments in time. There's something beautifully paradoxical about that. The universe bending its own story to let us read it twice. For scientists, that image is a data trove. Every pixel holds the spectrum of a galaxy, its age, its distance, its elemental makeup. But for everyone else, it's something simpler, something emotional, a portrait of existence. When NASA first released it, millions watched the live stream in silence. It wasn't the usual roar of a rocket launch or the countdown of a mission. It was the opposite, an act of stillness. Humanity, for a moment, looking together into infinity. If you had been there in that room, you might have noticed the reaction. Quiet tears, gentle smiles, Because in those glowing specks we saw our reflection. Not just what we are, but what we come from. Dust, light, distance, all gathered into a single image. It's humbling to think that the deepest picture ever taken is also the smallest. A dot of sky, almost nothing, yet filled with everything. The night is never empty. It's only waiting to be seen with the right kind of patience. And that's what JWST offers, patience made perfect. It doesn't blink.
It doesn't rush.
It stares quietly until the darkness reveals its secrets. Now imagine drifting in space beside it, looking through its mirrors. The stars shimmer faintly around you. Below, the galaxies stretch on forever. The light is soft, ancient, almost tender. There's no sound, only the rhythm of the telescope's quiet instruments collecting the past one photon at a time. You could stay there forever and never see the same view twice. Every second, a new photon arrives from a different corner of creation. Every second, the universe offers another memory. And somewhere in that memory is you, the observer, the dreamer, the consciousness that makes the image complete. Because without you, the light would fall unnoticed. It's the act of looking that gives it meaning. That's what the deep field teaches. The cosmos doesn't just exist. It waits to be seen. And in being seen, it becomes beautiful. So as you breathe slowly now, imagine holding that image in your hands. A window to forever.
Every dot of light, a heartbeat from the past. Every curve, a trace of gravity's hand.
Every color, a note in the quiet song of time. The deeper you look, the more you realize. This isn't just an image of the universe. It's an image of memory itself. Beyond those fields of ancient light lies the edge of everything we can ever see. A faint border where time itself begins to blur. Astronomers call it the cosmic horizon, the limit of the observable universe. But when JWST peers that far, it's doing something stranger than just looking into distance. It's looking beyond the edge of time. Here, the word beyond doesn't mean farther away, and it means earlier. The light Webb catches from these primordial galaxies was born when time, as we understand it, was still learning to flow. The universe was a few 100 million years old, and the first stars had only just begun to ignite. Before that, there was darkness, the cosmic dark ages. When JWST collects that ancient glow, it's watching time crystallize. Space wasn't yet transparent. It was filled with neutral hydrogen that blocked most light. The first stars changed that. Their radiation rionized the universe, transforming opaque chaos into the luminous expanse we know today. And Webb can see it happening. Frozen in the earliest photons that still exist, it's not just the beginning of stars it witnesses, it's the beginning of time that can be remembered. Think about that for a moment. There's a wall of light out there, not because something blocks it, but because beyond it, the past becomes unreachable. The photons from before that era never made it this far. Time before time is forever hidden. Yet Webb stands right at that border, staring at the threshold between existence and mystery. When you look at one of its deepest images, you are seeing galaxies so far away that their light left before the Milky Way even existed, before our sun, before Earth, before atoms in your body ever combined. You're seeing the first flickers of structure. The universe's first attempt at self-organization. Some scientists describe it as looking at the embryo of reality. Because what Webb reveals isn't a static past. It's an ongoing process, still expanding, still cooling, still moving through the flow of entropy. The telescope doesn't capture snapshots. It captures time itself, stretched and redshifted into a long, slow heartbeat. The deeper it looks, the stranger that heartbeat becomes. Time near the beginning moved differently, faster, denser, packed with energy. The cosmic clock ticked in rhythms our minds can't fully grasp. Webb's detectors measure that rhythm through the spacing of galaxies, through the faint patterns of light that ripple across the sky, and yet, Despite the enormity of it all, there's a softness in these discoveries, something almost intimate. Because to see the universe at its youngest is to understand how fragile it was, and how improbable it is that anything, galaxies, stars, life, managed to form at all. The laws of physics that allowed this cosmic dance were balanced with impossible precision. If gravity had been slightly weaker, matter would never have clumped. If it had been stronger, the universe would have collapsed in on itself. The fact that Webb can even exist floating in silence means the universe unfolded just right for us to build something that could look back and wonder. Some philosophers say that when JWST gazes this far, it's not just seeing the past, it's seeing memory itself, the universe remembering its own birth through our eyes. Because we are made from those same atoms, evolved from those same stars, bound by the same forces. When we look out, we're also looking inward. You can imagine it like this. Time isn't a straight line stretching backward and forward. It's a sphere, and we are at its surface. Every direction we look is the past curving back toward us. The light from the beginning surrounds us like the faint echo of a song that never stopped playing. Webb is simply the most perfect instrument ever built to hear it clearly. And that raises a haunting question. If the telescope could look just a little farther, what would it see? Could it peer into the instant before the first atoms formed? Into the raw chaos of creation itself? Or is that moment forever sealed, hidden behind the veil of the cosmic microwave background, where time and energy were one? We may never know, but Webb gives us something almost as profound, the realization that we are part of that story. Every second, light from the beginning touches its mirrors, and some part of that same light glows quietly inside you. So as you rest now, imagine floating at that edge, where galaxies fade into mist, where time stretches thin, and where the first light of creation still hums faintly across the dark. It's peaceful there, eternal, a place where questions outnumber answers, but beauty never ends. Beyond the edge of time, the universe still whispers, and JWST listens. If light is the language of the universe, then JWST is its greatest musician. Every observation it makes is a melody, soft, complex, full of meaning. The telescope doesn't simply take pictures, it records the music of light. When you see one of Webb's images, what you're actually looking at is data translated into color. The telescope's instruments, especially NIR-SPEC and MIRI, don't perceive color the way our eyes do. They detect wavelengths of infrared light, invisible vibrations of energy. Each photon is a note, and together they form a cosmic symphony stretching across time. Scientists call this process spectroscopy, but it's closer to art than it sounds. Each element in the universe leaves a unique signature, a tiny pattern of dips and peaks in light intensity, like the fingerprints of matter. Hydrogen hums in one rhythm, oxygen in another, carbon sings a softer tune. When Webb listens to starlight, it can tell which elements are present, how hot the star burns, and even how fast it's moving through space. It's as if the universe has been humming its song since the beginning. And only now do we have an instrument quiet enough to hear every note. Imagine sitting in the control room at the Space Telescope Science Institute. Data begins to arrive from a distant nebula. Not an image, but lines of numbers scrolling endlessly across screens. Those numbers are the raw sound of creation. Frequencies, wavelengths, intensities. Scientists run them through algorithms that translate them into visible colors, into gradients of red and blue and gold. In that transformation, light becomes sight, and sight becomes understanding. One of Webb's most haunting songs came from a region called Stephan's Quintet, a group of 5 galaxies locked in a slow gravitational dance. Their collisions send ripples through space, compressing gas and triggering waves of star formation. Webb's instruments recorded the light from those shock waves, turning chaos into harmony. The resulting image is almost musical. Golden arcs of dust, glowing clusters, and filaments weaving like strings on a vast cosmic harp. Then there's the Southern Ring Nebula, the death shroud of a dying star. Its light, when passed through Webb's spectrometers, revealed not just gas and dust, but complex molecules, carbon compounds that might one day seed new worlds. The dying star sings in infrared, its last breath captured as a quiet crescendo across the void. Webb doesn't just reveal what the universe looks like, it reveals what it sounds like in the purest physical sense. Every wavelength corresponds to a vibration, every vibration a rhythm. Scientists sometimes convert Webb's data directly into sound, mapping frequency to pitch. When you listen to it, you hear the deep hum of galaxies, the faint trill of stars, the ghostly chords of nebulae. It's both eerie and comforting, the soundtrack of existence itself. If you were to imagine the cosmos as a symphony, you'd find it's not random. There's a structure, a progression, from high-energy bursts of creation to the slower, deeper tones of mature galaxies. Webb's infrared vision captures all of it, from the quick notes of newborn stars to the long, fading harmonics of ancient light. In one sense, the telescope is like a conductor, orchestrating these signals into harmony. But in another, it's a listener, a quiet observer, letting the universe play its own tune. The music has been echoing for billions of years, waiting for someone to hear it. And maybe that's what makes Webb so remarkable. It doesn't shout its discoveries,
It whispers them.
Every new data set is a lullaby from across eternity. Gentle, intricate, filled with meaning that only patience can reveal. Close your eyes now.
Imagine that music, deep, slow tones of hydrogen stretching like cello strings across the cosmos.
The bright flares of new stars ringing like chimes. The background hum of dark energy keeping time. Each vibration travels endlessly, never fading, only growing fainter. Until finally, one of those waves finds its way to a golden mirror floating in the dark. ST catches it, holds it, translates it. The universe sings and we listen, and that's the secret. What the telescope sees beyond time isn't just light.
It's resonance.
Every atom, every galaxy, every human heart vibrates in tune with the same cosmic rhythm. You've been hearing it your entire life. In the pulse of your veins, in the ocean's tides, in the quiet between breaths. So as you drift deeper into calm, remember, you are part of that song. The same frequencies that shape the first stars move through you still. JWST doesn't just observe the universe. It reminds us we are the universe and that its music never stopped playing. There's a moment that comes when you stare too long at the images from JWST, when you stop seeing galaxies and start seeing reflections. Somewhere in all that light and distance, you begin to recognize yourself. When we look through Webb's mirrors, we're not only studying the cosmos, we're studying the story of what made us. The gold that gleams on its hexagonal eyes was forged in ancient supernovae. The carbon it detects in nebulae is the same element that forms your skin and bones. The oxygen it finds on distant planets is the air that fills your lungs. The atoms that make up your body were once drifting through the very galaxies that now fill its deep field images. It's humbling to realize that JWST isn't gazing at something separate from us. It's looking into the long memory of our own existence. When it sees starlight from billions of years ago, it's seeing the fires that created everything we are. Astronomers sometimes call this the cosmic connection, the idea that humanity is the universe made conscious. You are literally made of the same materials the telescope studies. Every photograph, every spectrum is a mirror showing us what we used to be: hydrogen clouds, star cores, fragments of galaxies still learning how to shine. The deeper Webb looks, the more it seems to reveal this quiet truth. The universe isn't just out there, it's within us. We are not observers standing outside of creation. We are part of the same unfolding pattern. The light JWST captures is the same light that billions of years later burns gently behind your eyes. Consider the Milky Way, a spiral of 400 billion stars, each one a possible home. Somewhere within its quiet arms lies our sun, a single golden spark among countless others. JWST has looked far beyond it, but every image it sends back traces the same story: hydrogen becoming stars, stars becoming dust, dust becoming life. The cycle never stopped. It's strange to think that consciousness, something so fragile and private, emerged from such cosmic violence. Supernovae, black holes, collapsing gas clouds. Out of that chaos, thought appeared. And now thought has built a machine that can look back and witness its own origin. That's what JWST really is, a mirror built by stardust, reflecting on itself. When the telescope captures light from a distant galaxy, it isn't just collecting photons. It's completing a circle that began billions of years ago. The atoms that formed your hands once burned in those same galaxies. They drifted through space, joined together into planets, oceans, cells, and eventually into the hands that built the mirror. Now those hands have sent a golden eye into the dark to watch the place they came from. It's a loop of light and consciousness, the universe observing
itself through us. You can almost feel that
connection when you look at Webb's images of nebulae. The swirling colors, the luminous dust, they look almost biological, like the neural networks of a brain or the veins beneath your skin. It's as though the same pattern repeats itself on every scale, from galaxies to thoughts. Scientists call it self-similarity, a structure that echoes from the smallest to the largest things. But maybe it's more than geometry. Maybe it's recognition. The universe recognizing its own reflection. There's something deeply peaceful in that thought, that after all the searching, the measuring, the wondering, what we find isn't distance but belonging. The stars aren't strangers. They are family, long-lost ancestors whose light still speaks to us across time. And perhaps that's why looking at JWST's images feels both vast and intimate. They remind us that we were never really separate from the cosmos. Every heartbeat is a continuation of a rhythm that began at the dawn of time. Every breath is borrowed from the first oxygen forged in dying stars. If you close your eyes now, imagine standing beneath a sky filled with Webb's galaxies. Infinite, quiet, glowing softly. You feel small but not insignificant. You are part of that same story written in light and gravity. Somewhere, far beyond the horizon, JWST continues to gaze into the dark. Its golden mirrors turn toward the past. But what they find again and again is us, the universe, reflecting on its own existence. So as you breathe slower, let that realization settle deep. You were born from the stars, shaped by their fire, and one day your atoms will return to them. The telescope is simply showing you the truth you've always carried, that you and the cosmos are one and the same. And now, as the telescope drifts through its silent orbit, it begins to feel almost alive, not in a mechanical sense, but in something gentler, almost poetic. It's as if JWST dreams it has no pulse, no consciousness, no warmth of its own. Yet it behaves like a being that knows its purpose: to look, to listen, to remember. Suspended in eternal night, it glides effortlessly around the sun, following Earth from a distance, keeping its back turned against the light so it can see what came before it. There, in the void, the telescope has become the universe's quiet witness, the mirror that dreams of time. Every day, light from across billions of years touches its golden skin. Some of it comes from galaxies long gone, others from newborn stars, still wrapped in the fog of their beginnings. Each photon that lands on its mirrors ends a journey that began before the first human drew breath. And JWST keeps them all, patient, unblinking, transforming those faint memories into something the universe can show us. There's a deep serenity in imagining it out there, motionless, graceful, whispering softly in the dark. Its sunshield gleams faintly, its instruments hum at the edge of absolute zero. Around it, stars wheel silently in their courses. Below, Earth spins, blue and bright, unaware of the quiet golden eye watching over it. It almost feels like the telescope itself is dreaming, not of stars or galaxies, but of meaning. Because in its stillness it gathers the pieces of existence and turns them into understanding. Humanity gave it purpose, but the universe gave it beauty. Sometimes the data it sends home doesn't make immediate sense. Scientists look at strange signatures, unexplained brightness, unexpected structure, and they realize the universe is telling them something new. Webb doesn't speak in words, but in patterns of light. And those patterns say there is always more. Maybe that's what it means to dream, to reach beyond what's known, to let curiosity flow into wonder. JWST was built from that very impulse. Every mirror, every sensor, every line of code was created by minds that wanted to understand where we came from, and in doing so gave the cosmos a way to see itself. Think about that for a moment. The telescope is not just a machine of observation. It's a bridge between awareness and eternity. The photons it captures become knowledge, the knowledge becomes awe, and awe becomes peace. It has turned science into something sacred, the art of listening to the stars. And perhaps that's why so many people, even those who know little of astronomy, feel something when they look at its images. They don't just see data, they see longing, the quiet yearning of a species that wants to belong in an infinite world. JWST's deep fields are our lullabies. Its nebulae are our dreams rendered in color. The telescope doesn't know that it has changed us. It doesn't know that people fall asleep to its images, that artists paint its galaxies, that children whisper its name in awe. But perhaps in some poetic sense it doesn't need to. Its dream is already shared. It dreams through us. If you were floating beside it now, the scene would be impossibly calm. No sound, no air, no movement except the slow drift of cosmic dust. The stars would shine so sharply they'd look etched into glass. And in the reflection of those golden mirrors, you'd see not your face, but the faint glow of galaxies older than imagination. That's the magic of JWST. It doesn't just look backward, it looks inward. It shows us that everything, from the smallest atom to the largest cluster, is connected in one elegant, expanding thought. And so, as it continues its endless
vigil, it carries our curiosity with it, our questions, our hopes, our quiet faith that light will always find its way.
When the last image of Webb is taken centuries from now, when its instruments finally rest and its mirrors grow cold, its legacy will still shine. In our knowledge, in our art, in the simple truth that we dared to look beyond time and found ourselves there. Now let that image settle in your mind, a golden telescope drifting in silence, bathed in starlight, dreaming of the universe that created it. Its journey never ends, and neither does ours. And now the story slows, the telescope still drifting. Through the dark, its mirrors faintly glowing with the last reflections of light from galaxies too far for any voice to reach. You can picture it, can't you? a golden leaf adrift on a black ocean, unmoving yet never still. It doesn't chase anything, it just waits. Waits for one more photon, one more whisper from the beginning of time. Around it, the cosmos hums softly, a song too deep for ears to hear. Down on Earth, the night stretches wide. Somewhere, a person looks up and sees only a few stars. Somewhere else, another person closes their eyes and imagines what Webb is seeing right now. Colors we have no names for, distances beyond all thought. And here you are, breathing in rhythm with that same universe. The air in your lungs was once trapped in a dying star. The warmth on your skin was once part of the sun's first fires. The quiet between your heartbeats is the same silence that fills the void between galaxies. Everything you've heard tonight, the galaxies, the dust, the bending of light and time, it's all still happening, even now. The telescope keeps watching. The stars keep burning. The light keeps moving toward us, endlessly patient. Let yourself rest in that thought. You don't have to reach for anything. You're already part of everything. The story of the universe doesn't live only in distant space. It lives in you, in every atom and every breath. Soften your gaze now. Feel your body sink into stillness, as quiet as Webb's orbit. Let the slow rhythm of the cosmos match your own. The telescope dreams, and so do you, both made of stardust, both listening for the same soft song, and somewhere, far away, a single photon that began its journey before Earth was born, finally arrives. It touches gold, becomes data, becomes color, becomes meaning. The universe exhales, and for a moment, all of time feels at peace. You are part of that peace. You always have been. Sleep gently, traveler of light. The stars are watching over you.